What if everything we thought we knew about the universe was just the tip of the iceberg? What if, beyond the stars and galaxies we see, there's an entirely different universe, one that could one day collide with our own? This isn't just science fiction. It's a question that some of the greatest minds in physics have dared to explore. From the vastness of space to the tiniest particles, the idea of two universes colliding challenges our understanding of reality itself. Could such an event rewrite the laws of physics? Would it create new dimensions or even destroy the fabric of existence as we know it? In this video, we're diving into the most fascinating theories about what could happen if two universes met and what it might mean for life, the cosmos, and everything in between. Get ready for a journey that will stretch your imagination and leave you questioning the very nature of reality. What exactly is a universe? At its core, a universe is everything that exists, all of space, time, matter, and energy, bound together by the laws of physics. Think of it as an unimaginably vast stage where stars, galaxies, black holes, and countless other cosmic phenomena play out their roles. But here's where it gets even more fascinating. What if our universe isn't alone? What if it's just one of many, floating in an even grander cosmic sea? This is where the idea of the multiverse comes in, a concept that suggests our universe might be just one bubble in a frothy ocean of realities. The multiverse theory isn't just science fiction. It's a serious area of study for some of the brightest minds in physics. Take, for example, the work of Stephen Hawking, who explored how multiple universes could arise from the same quantum processes that govern our own. Or Brian Greene, who has likened these universes to bubbles in a cosmic foam, each one expanding, evolving, and possibly even bumping into one another. These bubbles could be parallel universes existing alongside ours in dimensions we can't perceive, or they might be entirely separate realities with their own unique laws of physics. To help visualize this, picture a pot of boiling water. Each bubble that rises to the surface represents a universe, complete and self-contained. Some bubbles might be close enough to touch, while others drift far apart, never interacting. Now imagine what might happen if two of those bubbles collided. What would that look like? What forces would be at play? This isn't just a thought experiment. It's a question that physicists are actively trying to answer, and it's one that could reshape our understanding of reality itself. As we dive deeper into these ideas, we start to see how the boundaries between universes might not be as fixed as we once thought. Could there be moments where these vast cosmic structures interact, even briefly? And if so, what would that mean for the fabric of existence? These are the kinds of questions that set the stage for exploring the collision of universes, a topic as thrilling as it is mysterious. What if our universe wasn't the only one born from a cosmic explosion? The Big Bang Theory tells us that everything we know, the stars, planets, and galaxies, began as a single, unimaginably dense point that exploded into existence nearly 14 billion years ago. But what if that wasn't the only bang? What if, somewhere beyond the edges of our observable universe, other Big Bangs ignited, giving birth to entirely separate universes, each with its own unique laws of physics, dimensions, and timelines? Think of it like this. Imagine standing in a vast, starry field, watching fireworks burst into the sky. Each firework represents a universe born from its own explosive beginning. As they expand, their light and energy spread outward, creating vast, shimmering patterns. But here's the twist: these fireworks aren't alone. In this cosmic field, countless other fireworks are bursting at the same time, each one a universe expanding into its own space, unaware of the others. Now, let's take this idea further. Just as galaxies in our universe are racing away from each other, these separate universes might also be expanding, evolving, and growing independently. Some could be filled with strange forms of matter, others with forces we can't even imagine. They might exist in dimensions we can't perceive, or follow laws of physics that defy everything we know. But what happens when these expanding universes, each on its own path, begin to drift closer together? Picture two soap bubbles floating in the air. At first, they are separate, but as they grow, their edges start to touch. What happens at that moment of contact? Does one universe absorb the other? Do they merge into something entirely new? Or does the collision create chaos, shattering the delicate fabric of space and time? This is where the real mystery begins. As we explore the idea of multiple universes, the question isn't just about their existence, it's about what happens when they collide. And that collision could rewrite everything we think we know about reality itself. Picture this, a vast, higher-dimensional space, like an endless cosmic ocean, where universes aren't just solitary islands but rather floating bubbles, each containing its own unique set of physical laws and realities. This is the foundation of the bubble universe theory, one of the most fascinating ideas in cosmology. According to this theory, our universe might just be one of countless others, each existing as a self-contained bubble within a larger multiverse. These bubbles aren't static, they can grow, shift, and even collide with one another. So, what happens when two bubble universes collide? Think of it like two soap bubbles drifting toward each other. When they touch, their boundaries merge, creating a shared surface where the two bubbles become one. In the same way, if two bubble universes collided, their edges could merge, leading to a dramatic interaction between their respective physical laws and energies. The collision could release an enormous amount of energy, potentially reshaping both universes in ways we can barely comprehend. Stars, galaxies, and even the very fabric of space-time might be altered, creating entirely new cosmic landscapes. But here's where it gets even more intriguing. The energy released during such a collision wouldn't just be a simple explosion. It could trigger a cascade of events like ripples spreading across a pond. These ripples might carry information about the laws of the other universe, offering a glimpse into realities completely different from our own. Imagine the possibilities: new forms of matter, exotic particles, or even entirely unknown forces of nature. It's a cosmic dance of creation and transformation, where the boundaries between universes blur and something entirely new could emerge. Now, while the bubble universe theory paints a relatively orderly picture of collisions, not all theories are so harmonious. What if the interaction between universes wasn't a gentle merging but a violent, chaotic clash? That's where our next theory takes us, into a scenario where universes don't just collide, but crash with such force that the very laws of physics are thrown into disarray. But we'll get to that in just a moment. What if the collision of two universes sent shockwaves rippling through the fabric of existence itself? This brings us to the second theory, the cosmic ripple effect. When two universes collide, the immense gravitational forces involved could create massive ripples in space-time, gravitational waves on a scale we can barely comprehend. These waves wouldn't just be fleeting disturbances, they could fundamentally reshape the very structure of both universes, leaving behind an entirely new cosmic landscape. Think of it like dropping two pebbles into a still pond. The ripples from each pebble spread outward, colliding and overlapping, creating complex patterns on the water's surface. Now imagine those pebbles are entire universes, and the pond is the fabric of reality. The gravitational waves generated by such a collision could stretch and distort space-time, potentially sparking the birth of new stars, galaxies, or even entirely new physical laws. Entire regions of space might be compressed or stretched, leading to phenomena we've never observed before. Scientists have already detected gravitational waves here in our own universe, from events like black hole mergers and neutron-star collisions. These discoveries have given us a glimpse into how space-time behaves under extreme conditions, but a collision between universes that would unleash gravitational waves of unimaginable power far beyond anything we've ever recorded. The aftermath could be a cosmic reset where the rules we take for granted, like gravity or the speed of light, are rewritten. And here's where it gets even more intriguing. What if these ripples didn't just destroy but also created? The collision could trigger the formation of entirely new types of matter, or even open up regions of space where life could thrive under entirely different conditions. Could life survive or even evolve in such a chaotic, reshaped universe? The possibilities are as vast as the cosmos itself. What if the collision of two universes didn't just destroy or reshape them, but instead gave birth to something entirely new? This brings us to the third and perhaps most fascinating theory, the birth of a new universe. Imagine two universes, each with its own unique set of physical laws, dimensions, and constants, crashing into one another. The result, a cosmic reset where the rules of reality are rewritten, and an entirely new universe emerges from the chaos. It's like mixing two colors on a palette, blue and yellow combining to create green. But instead of colors, we're talking about the fundamental fabric of existence. Physicists have long speculated about such scenarios, suggesting that the collision could trigger a kind of cosmic reboot. The new universe might have entirely different physical constants. Gravity could be stronger or weaker, the speed of light could change, or even the number of spatial dimensions could shift. This isn't just science fiction. It's a serious area of study for scientists exploring the boundaries of cosmology. Some researchers propose that such collisions could explain why our own universe has the precise conditions necessary for life. Perhaps it too was born from a similar cosmic event. But what would this new universe look like? Could it be a place where time flows backward, or where matter behaves in ways we can't even comprehend? The possibilities are as vast as they are mind-bending. And here's the kicker. If such a universe were born, could we ever observe it? The answer is complicated. Because the new universe would operate under its own set of physical laws. It might exist in a way that's completely disconnected from our own, making it invisible to us. Or, if we're lucky, there might be subtle clues, ripples in space-time, or anomalies in the cosmic microwave background that hint at its existence. This theory challenges us to rethink not just the nature of our universe, but the very idea of existence itself. What if universes are constantly being born, colliding, and evolving in an endless cosmic dance? It's a humbling thought, reminding us just how much we have yet to discover about the cosmos. Now, let's shift our focus to a far more ominous possibility: the destruction of both universes in the event of a collision. Picture two cosmic giants, each with its own laws of physics, hurtling toward one another. When they meet, the sheer force of their impact could unleash an unimaginable amount of energy, enough to unravel the very fabric of both realities. Think of it like two soap bubbles colliding in mid-air. Instead of merging or bouncing apart, they burst into nothingness, leaving behind only a fleeting ripple. In this scenario, the collision wouldn't just disrupt the structure of the universes, it would obliterate them entirely. The energy released could tear through space-time, creating shockwaves that erase stars, planets, and even the fundamental forces that hold matter together. This isn't just an explosion, it's a cosmic unraveling where the building blocks of existence are pulled apart at their seams. One key factor in this catastrophic outcome is entropy, the measure of disorder in a system. In a universe, entropy tends to increase over time, leading to more chaos and less structure. When two universes collide, their combined entropy could skyrocket, pushing both systems toward a state of complete disarray. It's like shaking a snow globe so violently that the snow never settles. It just keeps swirling until everything inside is unrecognizable. The scale of such destruction is almost impossible to comprehend. Imagine the brightest supernova you've ever seen, then multiply its intensity by billions. That's the kind of cosmic explosion we're talking about. A flash of light and energy so immense that it wipes out not just galaxies but entire dimensions. It's a sobering reminder of how fragile even the grandest structures in the cosmos can be. But while this theory paints a bleak picture, it also sets the stage for a more hopeful idea. What if, instead of destruction, the collision could lead to something entirely new? What if the energy released could give birth to an entirely different kind of universe, one that combines the best of both worlds? That's where our next theory comes in, offering a glimmer of possibility amid the chaos. What if the collision of two universes didn't just create chaos, but instead rewrote the very rules of reality? This brings us to the fifth theory, the merging of physical laws. Imagine two universes, each with its own unique set of rules governing gravity, light, and even the behavior of matter. When they collide, these laws could blend, creating a cosmic mashup of physics unlike anything we've ever seen. Think about gravity for a moment. In our universe, it's a force that pulls objects together. But what if the other universe operates with a different gravitational constant? One where gravity is weaker, stronger, or even repulsive. The result could be a bizarre hybrid where objects behave in ways that defy our current understanding. Planets might float effortlessly, or stars could collapse under their own weight in an instant. And then there's light. In our universe, light travels at a constant speed, but what if the other universe has a different speed of light? The merging of these laws could lead to light behaving in unpredictable ways, bending, slowing, or even stopping altogether. Imagine a world where shadows move faster than the objects casting them, or where the colors we see are entirely alien to our own spectrum. Quantum mechanics adds another layer of strangeness. In the quantum realm, particles can exist in multiple states at once, and their behavior is governed by probabilities. If the physical laws of two universes merge, these probabilities could shift in ways that make the quantum world even more unpredictable. Particles might appear and disappear at random, or entanglement, where particles are connected across vast distances, could become even more bizarre, linking objects across not just space but entire universes. The aftermath of such a collision could give rise to entirely new forms of matter and energy. Imagine materials that are neither solid nor liquid, or energy that flows in patterns we can't even begin to comprehend. The possibilities are as limitless as they are mind-bending. What would life look like in a universe where the rules are constantly shifting? Could we even survive in such a place? This blending of physical laws opens the door to questions that challenge our understanding of reality itself. It's a reminder that the universe or universes are far stranger and more complex than we often give them credit for. And as we ponder these possibilities, we're left wondering, could such a collision not only reshape the cosmos but also redefine what we think is possible? What if the collision of two universes opened up gateways to the unknown, doorways that could change everything we think we know about space, time, and reality itself? This brings us to the sixth theory, the creation of wormholes. When two universes collide, the immense energy and gravitational forces at play could potentially rip open tunnels through the fabric of space-time, creating wormholes. These cosmic shortcuts wouldn't just be bridges between distant points in space, they could connect the two universes themselves. Imagine a wormhole as a cosmic subway system, linking two entirely separate realities. If such a phenomenon were to occur, it could allow for travel or even communication between these universes. Picture sending a message, or even a spacecraft through one of these tunnels, emerging in a universe with its own unique laws of physics, stars, and perhaps even life. The implications are staggering. For one, it could revolutionize our understanding of time. Wormholes are often theorized to bend time, meaning they could serve as portals not just to other places, but to other times as well. Could we use them to revisit the past or leap into the far future? The possibilities are as thrilling as they are mind-bending, but it doesn't stop there. If wormholes were stable enough, they could offer a way to explore other realities, universes where the fundamental constants of nature are different, where black holes behave in unexpected ways, or where entirely new forms of matter exist. The scientific and philosophical questions this raises are endless. Would these universes be hospitable to us? Could we coexist with beings from another reality? And what would it mean for our own universe if we could interact with another? Of course, the idea of harnessing such a phenomenon is still firmly in the realm of speculation. The energy required to create or stabilize a wormhole would be beyond anything we can currently imagine. Even if it were possible, the risks would be enormous. What if a wormhole destabilized, trapping us in another universe or worse, collapsing and destroying both realities in the process? So, could we ever harness such a phenomenon? The answer, for now, lies somewhere between the boundaries of science and science fiction. But one thing is certain. The collision of two universes wouldn't just be a cosmic spectacle, it could be the key to unlocking the greatest mysteries of existence. Imagine if the collision of two universes didn't just reshape stars and galaxies, but also stirred up the invisible forces that hold everything together. This brings us to the seventh theory, the potential emergence or dramatic alteration of dark matter and dark energy. These mysterious components make up the vast majority of our universe, yet we can't see them directly. Dark matter acts as cosmic glue, holding galaxies together, while dark energy drives the universe's accelerating expansion. Now, picture what might happen if two universes collided. Could such an event amplify these forces or even alter their behavior entirely? In a collision scenario, the sheer gravitational pull and energy exchange between universes could create ripples in the fabric of dark matter. Galaxies, which are currently held in place by dark matter's gravitational influence, might suddenly find themselves adrift, their structures unraveling. On the other hand, dark energy, the force pushing the universe apart, could either intensify or weaken. If it intensifies, the expansion of the cosmos might accelerate at an unprecedented rate, stretching space faster than light can traverse it. Conversely, if dark energy weakens, the universe could slow its expansion, potentially even collapsing in on itself over billions of years. To put this into perspective, think of dark matter and dark energy as the hidden gears of a cosmic clock. If the clock is struck by an outside force like a universe collision, those gears might shift, throwing the entire mechanism out of sync. And while we can't see these forces directly, their effects are undeniable. For instance, without dark matter, galaxies would fly apart, and without dark energy, the universe might not have expanded to its current size. A collision could rewrite the rules governing these invisible powers, reshaping the very foundation of reality. But what does this mean for life as we know it? If dark matter and dark energy were altered, the stability of galaxies and the planets within them could be compromised. Stars might drift apart and habitable zones could vanish. This leads us to the next intriguing question. Could life survive in a universe where the fundamental forces have been rewritten? That's where our eighth theory comes into play, exploring the profound implications for life in a post-collision cosmos. What if life could not only survive the collision of two universes but thrive in its aftermath? This brings us to the eighth theory, the survival of life. If universes collided, the sheer scale of destruction might seem insurmountable, but life has proven itself to be remarkably resilient. On Earth, we've discovered extremophiles organisms that thrive in environments once thought uninhabitable. From the crushing pressures of deep-sea trenches to the scorching heat of volcanic vents, life finds a way to adapt. Could this same resilience extend to a universe-scale cataclysm? Imagine a scenario where life clings to stability amid chaos. In the aftermath of a collision, certain regions of the newly merged universe might retain habitable conditions. These pockets of stability could become sanctuaries for life, offering a chance for survival. Over time, life might even adapt to new physical laws, evolving in ways we can barely fathom. Just as extremophiles on Earth have evolved to endure extreme environments, life in a merged universe could develop entirely new survival strategies. But here's where it gets even more fascinating. A collision of universes might not just preserve existing life, it could create entirely new forms of it. The merging of different physical constants and laws could give rise to environments where life evolves in ways we've never seen. Picture organisms that harness energy from exotic particles or thrive in dimensions beyond our comprehension. The possibilities are as vast as the cosmos itself. This theory challenges us to think beyond the limits of our current understanding. If life can endure and adapt in the face of such monumental upheaval, what might it look like in a universe reshaped by collision? The answer could redefine our place in the cosmos. And as we ponder this, one question lingers: could humanity or any form of life be part of this extraordinary journey? Now, let's take this idea a step further. What if the collision itself becomes a catalyst for life rather than its end? The merging of two universes might create conditions ripe for the emergence of entirely new ecosystems. Just as the early Earth provided the perfect conditions for life to arise, a universe collision could set the stage for a cosmic rebirth. It's a thought that stretches the imagination, reminding us that the universe is full of surprises. Now, let's step into the fascinating realm of time itself. What if, during a collision between two universes, time didn't flow uniformly? This is where Einstein's theory of relativity comes into play, offering a mind-bending perspective. According to relativity, time isn't constant. It can stretch, compress, or even appear to stop depending on the conditions. Imagine two universes colliding, each with its own gravitational forces and energy densities. In some regions, time might slow down dramatically, almost as if it's crawling, while in others, it could race forward at an accelerated pace. Think of it like this: if you were an observer in a region of intense gravitational pull caused by the collision, time for you might feel sluggish compared to someone in a less affected area. This phenomenon, known as time dilation, suggests that the very fabric of time could warp in unpredictable ways. For instance, a minute in one part of the colliding universes might feel like an hour in another. It's a concept that challenges our everyday understanding of time as a steady, unchanging force. Einstein's theories give us a framework to explore this idea. His work showed that massive objects like stars or black holes can bend space-time, altering how time flows around them. Now, scale that up to the collision of entire universes. The gravitational forces at play would be unimaginable, creating pockets where time behaves in ways we can barely comprehend. So, what would this mean for any hypothetical observers caught in the mix? If you are watching from a slow time zone, you might see events in a fast time zone unfold in a blur, like a sped-up movie. Conversely, someone in the fast time zone might perceive your actions as frustratingly slow, almost frozen. The collision wouldn't just reshape space, it could shatter our perception of time itself. This raises another intriguing question: could life even exist in such extreme conditions? Or would the distortions in time make it impossible for any form of consciousness to adapt? It's a thought that pushes the boundaries of both physics and imagination. What if the collision of two universes didn't just reshape reality as we know it, but also left behind something far stranger: cosmic strings? These one-dimensional defects in space-time could be the fingerprints of a cataclysmic event, a remnant of the unimaginable forces at play when two universes collide. Think of them like cracks in glass. When something shatters, the fractures spread in unpredictable patterns, leaving behind lines of weakness. In the same way, cosmic strings could form as a result of the immense tension and energy released during such a collision, creating ripples in the very fabric of space-time. But what exactly are these cosmic strings, and why do they matter? Imagine space-time as a smooth, flat sheet. When a cosmic string forms, it's like pulling a thread through that sheet, creating a tiny but incredibly dense line of distortion. These strings are theorized to be unimaginably thin, yet they could carry immense gravitational effects. A single cosmic string might bend light around it, distorting the images of distant galaxies, or even create bizarre gravitational lensing effects that astronomers could potentially observe. Some scientists speculate that these strings could even influence the large-scale structure of the universe, acting like invisible threads weaving through the cosmos. Now here's where it gets even more fascinating. cosmic strings aren't just static remnants, they could be dynamic, vibrating and oscillating over time. These vibrations might produce gravitational waves, ripples in space-time that we've only recently begun to detect. If cosmic strings exist, they could be a hidden source of these waves, offering us a new way to study the universe's most mysterious phenomena. And while we haven't directly observed cosmic strings yet, their potential existence opens up a whole new realm of possibilities for understanding the universe's structure and history. But cosmic strings aren't the only bizarre outcome of a universe collision. As we dive deeper into the aftermath of such an event, we find ourselves at the intersection of quantum mechanics and cosmology, a place where the rules of the very small meet the mysteries of the very large. What happens when quantum mechanics enters the picture? That's where things take an even stranger turn. What if the collision of two universes didn't just create chaos, but also forge connections at the most fundamental level of reality? This brings us to the 11th theory, quantum entanglement across universes. Quantum entanglement, often dubbed spooky action at a distance by Einstein, is the phenomenon where particles become linked, sharing properties instantaneously no matter how far apart they are. But what happens to entanglement when two universes collide? Could particles in one universe become entangled with particles in another, creating a bridge between these cosmic realms? Let's break this down. In our universe, quantum entanglement has been demonstrated in countless experiments. For instance, scientists have entangled particles and separated them by vast distances, even across continents, only to find that measuring one instantly affects the other. This connection defies classical physics and suggests that entangled particles share a deeper, invisible bond. Now, imagine this principle stretched to its ultimate limit. Particles from two different universes, each with their own unique laws of physics, becoming entangled. The implications are staggering. During a universe collision, the boundaries between the two realities could blur, allowing particles from each to interact in ways we can barely comprehend. If entanglement were to occur across universes, it might create a kind of quantum handshake, enabling information or energy to flow between them. This could lead to entirely new phenomena, like universes influencing each other's quantum states or even sharing resources. It's a concept that pushes the boundaries of our understanding of reality itself. But why does this matter beyond the realm of theoretical physics? If such entanglement were possible, it could open the door to revolutionary quantum technologies. Imagine devices that harness the power of inter-universal entanglement, enabling communication or computation across cosmic scales. While this might sound like science fiction, it's rooted in the same principles that underpin quantum mechanics today. The collision of universes might just be the key to unlocking technologies we've only dreamed of. As we ponder this extraordinary possibility, it's worth considering how such discoveries could reshape our understanding of the cosmos and our place within it. Could the entanglement of universes reveal hidden connections that bind all of reality together? And if so, what might that mean for the future of science and technology? The answers lie in exploring the quantum threads that could weave universes together. What if the collision of two universes brought their most mysterious and destructive forces face to face? Black holes, the enigmatic giants of spacetime, could play a starring role in such a cosmic encounter. Imagine two supermassive black holes, each anchoring its own universe, suddenly finding themselves on a collision course. What happens when these gravitational titans meet? The result could be nothing short of spectacular and terrifying. When two black holes come close enough, they begin to orbit one another, spiraling inward as they lose energy. This dance isn't silent, though. As they move, they send ripples through the fabric of spacetime itself, gravitational waves. These waves are like cosmic echoes, carrying information about the black hole's masses, speeds, and eventual merger. If two supermassive black holes from colliding universes were to merge, the gravitational waves produced would be unimaginably powerful. picture the shockwaves rippling across both universes, distorting time and space on a scale we can barely comprehend. But what happens after the merger? The result would likely be a single, even more massive black hole, a gravitational behemoth capable of reshaping the surrounding cosmos. This new black hole could act as a bridge between the two universes, creating a chaotic yet fascinating region where the laws of physics as we know them might bend or break. The energy released during this merger could also trigger the formation of new stars, galaxies, or even entirely new structures we've never seen before. As we ponder the role of black holes in a universe collision, it's worth asking, what comes next? What happens to the remnants of these universes after such a cataclysmic event? The aftermath could hold clues to the very nature of existence itself, and that's where our next theory takes us. What happens when two black holes, each a gravitational powerhouse, come face to face in a cosmic collision? The aftermath of such an event is nothing short of spectacular. When black holes merge, they unleash an incredible amount of energy rippling through space-time itself. These ripples, known as gravitational waves, have been detected by observatories like LIGO and Virgo, giving us a front-row seat to some of the most violent events in the universe. But the energy released isn't the only fascinating outcome. These mergers often result in the birth of a single, more massive black hole, a cosmic heavyweight born from the union of its predecessors. Take, for example, the historic detection of gravitational waves in 2015. Scientists observed the merger of two black holes, each about 30 times the mass of our Sun. The collision released energy equivalent to 3 suns being converted into gravitational waves in a fraction of a second. It's a staggering amount of power, and it hints at the sheer scale of these events. But here's where it gets even more intriguing. The newly formed black hole doesn't just sit quietly. It can spin at incredible speeds, distorting space-time around it and potentially influencing its surroundings in profound ways. Now, let's zoom out and consider the bigger picture. Could these black hole mergers play a role in shaping entire galaxies? Some theories suggest that supermassive black holes, like the one at the center of our Milky Way, may have grown to their enormous sizes through repeated mergers over billions of years. These colossal black holes are thought to influence the formation and evolution of galaxies, acting as gravitational anchors that pull stars and gas into swirling disks around them. So, while a single merger might seem like a localized event, its effects could ripple outward, setting the stage for new galactic structures. Could these cataclysmic collisions be the architects of future galaxies? The answer might lie in the delicate dance between destruction and creation that defines our universe. Now, let's turn our attention to one of the most awe-inspiring possibilities that could arise from a collision between two universes, the birth of entirely new galaxies. Picture this: two vast cosmic realms, each teeming with stars, gas, and dust crashing into one another. The result, a cosmic crucible, a chaotic yet fertile environment where gravity takes the reins. Gas and dust from both universes would mingle, clumping together under gravitational forces, sparking the formation of brand new galaxies. It's like a cosmic dance where chaos gives way to creation and the universe or universes begin to rebuild themselves. Galaxy formation is a process driven by gravity pulling matter together, but it's also fueled by the raw materials of the cosmos, gas and dust. These elements serve as the building blocks for stars, which then gather into galaxies. In the aftermath of a universe collision, the sheer amount of gas and dust present would create an incredibly dense and active environment. Think of it as a cosmic construction site where gravity acts as the foreman, directing the assembly of new structures. Over time, these swirling clouds of material would condense, ignite, and give rise to stars, which would then cluster together into galaxies. To visualize this, imagine a vast, glowing nebula, a cloud of gas and dust illuminated by the light of newborn stars. Now multiply that by the scale of an entire universe. The collision would create countless such regions, each a potential birthplace for a galaxy. And within these galaxies, the process could repeat on a smaller scale, leading to the formation of solar systems and even planets. It's a breathtaking cascade of creation, all set in motion by the collision of two universes. What's truly fascinating is the potential for diversity in these newly formed galaxies. The unique mix of materials from two separate universes could give rise to galaxies unlike anything we've ever observed. Some might be dense and packed with stars, while others could be more diffuse with vast regions of open space. The possibilities are as endless as the cosmos itself, but the story doesn't end there. Within these galaxies, the conditions might just be right for the emergence of new solar systems, and perhaps even planets capable of supporting life. The collision of universes, while cataclysmic, could ultimately set the stage for new beginnings on a scale that's almost impossible to comprehend. And that, perhaps, is the most profound takeaway. Even in the chaos of destruction, the seeds of creation are sown. When two universes collide, the sheer scale of energy and matter involved could set the stage for something extraordinary, the birth of entirely new solar systems. Picture the aftermath of such a collision: vast clouds of gas and dust swirling together, pulled by gravity into dense pockets. Over time, these pockets could collapse under their own weight, igniting new stars and forming planets around them. It's almost like a cosmic reset button, where the chaos of a collision gives rise to fresh opportunities for creation. What's even more fascinating is the possibility that some of these new planets might fall into what we call the habitable zone, the perfect distance from their star to support liquid water, a key ingredient for life as we know it. We've already discovered thousands of exoplanets in our own universe, some of which orbit within their star's habitable zone. Take, for example, Proxima Centauri b, a planet located just over 4 light-years away. It's a rocky world that could potentially host liquid water, sparking excitement about its habitability. If a universe collision created similar conditions, who's to say it couldn't lead to the emergence of life elsewhere? But here's the twist: the creation of new solar systems wouldn't just be about the potential for life. It would also raise questions about how existing life forms, those already thriving in either universe, might be affected. If a collision reshapes entire galaxies and spawns new worlds, what happens to civilizations already living in those regions? This brings us to our next theory, where we'll explore the impact of such a collision on life as we know it. What if, somewhere out there, an advanced civilization has already faced the unimaginable, a collision between universes? How would a society, far more technologically evolved than our own, respond to such a cataclysmic event? The idea might sound like the plot of a sci-fi blockbuster, but it raises fascinating questions about survival, adaptation, and the limits of ingenuity. Imagine a civilization that has mastered the art of harnessing energy from stars, bending space-time to their will, or even creating artificial habitats that defy the laws of physics as we know them. For them, a universe collision might not spell instant doom, but instead present a monumental challenge, one they could potentially overcome. They might deploy colossal structures like Dyson spheres, or even entire megastructures designed to absorb or redirect the immense energy released during such an event. Or they could develop technologies to detect the collision long before it occurs, giving them time to prepare for the inevitable. Migration could also be a viable option. Advanced civilizations might have the capability to relocate entire populations to safer regions of space, or even to other dimensions if such a feat is within their grasp. Think of the iconic Ringworld from Larry Niven's science fiction series, a massive artificial habitat that could serve as a refuge in the face of cosmic upheaval. Or consider the culture novels by Ian M. Banks, where post-scarcity societies thrive in immense, self-sustaining ships that roam the galaxy, free from the constraints of planetary systems. But even with all their technological prowess, could such civilizations truly survive a universe collision? the answer might depend on how early they detect the event. Early detection could mean the difference between a well-executed evacuation plan and total annihilation. Advanced sensors, perhaps capable of detecting subtle distortions in spacetime or anomalies in cosmic background radiation, might give them the critical warning they need. And if they are able to predict the collision, could they even attempt to prevent it? The possibilities are as thrilling as they are speculative. This brings us to a question that ties directly into our own reality. Could we, as a civilization still bound to a single planet, detect a universe collision before it happens? What would it take for us to develop the technology to sense such an event, let alone respond to it? The answers might lie in the stars or perhaps in the very fabric of existence itself. What if we could detect the collision of two universes before it even happens? While it might sound like science fiction, scientists have been exploring ways to spot the signs of such a cataclysmic event. One of the most promising tools in this search is gravitational waves, ripples in the fabric of spacetime caused by massive cosmic events. These waves, first detected in 2015, could carry clues about the interactions between universes. Imagine a universe brushing against another, creating gravitational ripples that travel across dimensions. If we could capture these signals, they might serve as an early warning system, alerting us to the possibility of a collision long before it occurs. Another key piece of the puzzle lies in the cosmic microwave background radiation, or CMB. This faint glow left over from the Big Bang acts like a cosmic fingerprint, revealing the history of our universe. If another universe were to collide with ours, it could leave distortions or anomalies in the CMB, like a cosmic echo of the event. Researchers have already started scanning the CMB for unusual patterns, hoping to find evidence of such interactions. For instance, anomalies like the cold spot in the CMB, a region of unexpectedly low temperature, have sparked theories that it could be a scar from a past collision with another universe. Beyond gravitational waves and the CMB, other signals might also hint at an impending collision. Dark energy, the mysterious force driving the expansion of our universe, could behave differently if another universe were nearby. Changes in the distribution or behavior of dark energy might serve as subtle indicators of a neighboring universe closing in. Additionally, strange particle interactions or unexpected shifts in the fundamental constants of physics could offer further clues. These signs, while subtle, could provide scientists with the data needed to piece together the story of a universe collision. The search for these signals isn't just theoretical, it's already happening. Advanced observatories like the Laser Interferometer Gravitational Wave Observatory, or LIGO, are constantly listening for gravitational waves. Meanwhile, space telescopes such as the Planck satellite have been mapping the CMB in incredible detail, hunting for irregularities. Each discovery brings us closer to understanding whether our universe is truly alone, or if it's on a collision course with another. The ability to detect these signs early wouldn't just satisfy our curiosity, it could fundamentally change how we understand the cosmos. And who knows, one day, the faint signals we detect might just rewrite the story of everything we thought we knew. So, how do scientists even begin to predict what might happen if two universes collided? The answer lies in the powerful language of mathematics. Mathematics isn't just about numbers, it's a tool that allows us to model the unimaginable. When it comes to the collision of universes, physicists rely on complex equations and simulations to explore potential outcomes. These models help us visualize scenarios that are otherwise beyond our reach, like how two universes might interact, merge, or even tear each other apart. One of the key tools in this process is something called numerical relativity. This branch of physics uses supercomputers to solve Einstein's equations of general relativity, which describe how space and time behave under extreme conditions. By feeding these equations into simulations, scientists can create virtual collisions, tweaking variables like the density of matter, the curvature of space-time, or the presence of dark energy. These simulations don't just give us a snapshot of what might happen, they also help us understand the underlying principles that govern such cosmic events. For example, imagine two universes, each with its own unique structure and laws of physics, hurtling toward each other. Mathematical models could predict whether they'd merge into a single, larger universe, or if they'd create something entirely new, like a chaotic, unstable region where the laws of physics as we know them might break down entirely. And while these predictions are theoretical, they're grounded in the same math that has successfully explained phenomena like black holes and gravitational waves. But here's where it gets really fascinating. Even with all this computational power, there's still a lot we don't know. The equations we use are based on our current understanding of physics, and if two universes with entirely different laws collided, those equations might need to be rewritten. This uncertainty is part of what makes the idea so thrilling. It pushes the boundaries of what we can predict and forces us to think creatively about the nature of reality. As we dive deeper into the mathematics of universe collisions, it's hard not to wonder about the bigger questions. What does it mean for two realities to collide? Could such an event reshape our understanding of existence itself? These questions lead us to the next theory, which shifts from the realm of physics to philosophy, exploring the profound implications of a multiverse collision on our perception of reality. What if the collision of two universes didn't just rearrange the stars and galaxies, but also shattered our very understanding of reality itself? This brings us to the 19th theory, the philosophical implications of a universe collision. Beyond the physics and the cosmic spectacle, such an event would force us to confront questions that have puzzled humanity for centuries. What is reality? What defines a universe, and if two universes collide, do the rules of existence as we know them still apply? Philosophers have long grappled with the nature of reality. Thinkers like René Descartes questioned whether our perceptions are reliable, famously declaring, "I think, therefore I am." But in the aftermath of a universe collision, even that foundational idea might be up for debate. If two universes with entirely different physical laws merged, could we trust our senses to interpret the new reality? Or would we find ourselves in a realm where logic itself is rewritten? Scientists, too, have pondered these questions. Stephen Hawking once said, "The universe doesn't allow perfection." But what if the collision of two universes created a new, imperfect harmony, one where the laws of physics blend in ways we can't yet imagine? This collision wouldn't just be a physical event. It could redefine the very fabric of existence, challenging our most deeply held beliefs about space, time, and the nature of the cosmos. Imagine for a moment that a universe collision introduces entirely new dimensions or realities, ones where time flows backward or gravity behaves unpredictably. How would we, as beings bound by the rules of our current universe, adapt to such a paradigm shift? Philosopher Immanuel Kant argued that our understanding of reality is shaped by the structures of our mind. But if those structures no longer align with the new universal order, would we even recognize the world around us? This collision could also blur the line between what we consider real and imaginary. If two universes merge, creating a hybrid reality, would we still be able to distinguish between the two? Or would we find ourselves in a multiverse where every possibility coexists simultaneously? It's a thought that echoes the ideas of quantum mechanics, where particles exist in multiple states until observed. Could a universe collision force us to accept that reality is far more fluid than we've ever imagined? As we ponder these questions, one thing becomes clear. A universe collision wouldn't just be a scientific event, it would be a philosophical revolution. It would challenge us to rethink not only the cosmos but also our place within it. And in doing so, it might open the door to entirely new paradigms of thought, reshaping how we understand existence itself. What if the collision of two universes didn't just reshape the cosmos, but also challenged the very foundations of what we believe? This brings us to the 20th theory, the impact on religion and spirituality. Across cultures and throughout history, humanity has turned to stories, myths, and sacred texts to make sense of the universe. But what happens when the universe itself undergoes a cataclysmic event like a collision with another universe? Would it shake our spiritual beliefs to their core, or would it inspire entirely new ways of understanding existence? Consider creation myths from around the world. Many cultures already have stories about the birth of the cosmos, often involving chaos, order, and divine intervention. The collision of two universes could give rise to a modern-day creation myth, blending science with spirituality. Imagine a future where theologians and scientists work side by side, interpreting the event as both a physical phenomenon and a spiritual awakening. For some, it might even be seen as a divine act, a moment when the boundaries between worlds were dissolved and a new reality was born. But it's not just about new stories. Existing religious frameworks might also evolve. Take Buddhism, for example, which already embraces the concept of interconnectedness and infinite universes. A collision could reinforce these teachings, offering a tangible example of the impermanence and interdependence of all things. Similarly, monotheistic religions might reinterpret the event as a sign of divine power, while indigenous traditions could see it as a cosmic dance between forces of creation and destruction. The possibilities are as vast as the universes themselves, and then there's the question of spirituality on an individual level. How would people reconcile their personal beliefs with such a monumental event? Some might find their faith strengthened, viewing the collision as evidence of a higher plan. Others might feel a crisis of meaning, questioning the role of humanity in a universe where even the cosmos itself isn't stable. It's a profound moment that could redefine not just what we believe, but why we believe it. As we ponder these spiritual and philosophical implications, let's not forget that the collision of universes isn't just a physical event, it's a deeply human one. It challenges us to ask what it means to exist, to believe, and to seek meaning in an ever-changing reality. And with that, we turn to the next theory, the role of consciousness in a multiverse collision. Could our awareness of such an event shape the outcome itself, or even the nature of reality? Let's dive in. What if consciousness isn't just a product of our universe, but something far more profound? As we dive into the 21st theory, let's consider how a collision between universes might reshape not just physical reality, but the very fabric of awareness itself. Could consciousness, that mysterious force that allows us to perceive and interpret the world, be influenced or even transformed by such a cosmic event? From a scientific perspective, consciousness is often studied through the lens of neuroscience and psychology. We know it arises from the complex interactions of neurons in our brains, but could it also be tied to the deeper structures of the universe? Some theories, like integrated information theory, suggest that consciousness might be a fundamental property of the cosmos, not unlike space or time. If that's true, then a collision between universes could potentially disrupt or reconfigure the systems that give rise to awareness. Imagine a scenario where the merging of two universes creates entirely new states of consciousness, states we can't even begin to comprehend. Take collective consciousness, for example. This idea, often explored in psychology and even certain spiritual traditions, suggests that individual awareness might be part of a larger, interconnected network. In the context of a universe collision, this network could expand or fracture, leading to experiences of shared thoughts, emotions, or even memories across beings in both universes. It's a mind-bending thought. What if, in the aftermath of such an event, we suddenly found ourselves connected to minds from an entirely different reality? Neuroscience also offers intriguing possibilities. Altered states of consciousness, like those experienced during deep meditation or under the influence of psychedelics, show us that the brain is capable of shifting its perception of reality. If a universe collision disrupted the fundamental constants of physics like the speed of light or the strength of gravity, could it also trigger similar shifts in how consciousness operates? Might we experience reality in ways that are utterly alien to us now? And then there's the big question, could consciousness transcend universes altogether? If consciousness is indeed a fundamental aspect of existence, perhaps it exists independently of any single universe. In that case, a collision might not destroy or alter it, but instead reveal its true nature, a universal force that binds all realities together. This theory challenges us to think beyond the physical and consider the metaphysical. It invites us to explore not just what happens to galaxies and particles in a universe collision, but what happens to us, our thoughts, our awareness, our very sense of being. Could a collision between universes unlock new dimensions of consciousness, or even redefine what it means to be aware? The answers might lie somewhere between the science of the mind and the mysteries of the cosmos, waiting to be discovered. What if a collision between two universes didn't just create chaos, but opened a door to something extraordinary: communication across dimensions? The idea of multiverse communication might sound like science fiction, but when we consider the possibilities, it's a concept that bridges the gap between imagination and cutting-edge science. If universes collided, the boundaries that once kept them separate could potentially break down, creating pathways for information or even matter to flow between them. Think about quantum communication, a field that's already pushing the limits of how information can travel. In our own universe, scientists have experimented with quantum entanglement, where particles can instantaneously affect each other, no matter the distance. Now imagine scaling that up to a multiverse level. If entangled particles could exist in both universes, could they serve as a kind of cosmic telegraph, sending signals across the divide? It's a tantalizing thought, and one that challenges our understanding of physics as we know it. But communication might not stop at information. Some theories suggest that matter itself could be exchanged in the aftermath of a collision. Picture this: particles from one universe slipping through cracks in space-time, introducing entirely new elements or even life forms into another. While this raises countless questions, like how such interactions would be governed or what the consequences might be, it also hints at the potential for entirely new forms of interaction, ones we can barely begin to comprehend. As we explore these ideas, it's worth asking, what would it mean for humanity if we could tap into this kind of connection? The possibilities are as vast as the multiverse itself, and they invite us to rethink not just the nature of reality, but our place within it. What if a collision between universes didn't just shake up the cosmos as we know it, but actually open the door to entirely new dimensions? According to some theories, such an event could tear through the fabric of space-time, revealing hidden layers of reality we've never seen before. This isn't just science fiction, it's a possibility rooted in ideas like string theory, which suggests our universe might be just one slice of a much larger, multidimensional reality. If two universes collided, the sheer force of that impact could create ripples through these unseen dimensions, or even give rise to entirely new ones. Imagine space-time as a folded piece of paper. A collision could be like punching a hole through it, exposing parts of the paper or dimensions that were previously hidden. The implications for physics would be staggering. New dimensions could mean new laws of nature, forces we've never encountered, or even entirely different ways for matter and energy to interact. For instance, in string theory, particles aren't just tiny dots, they're vibrating strings, and their vibrations depend on the number of dimensions they exist in. A collision that alters or adds dimensions could fundamentally change how these strings behave, reshaping everything from gravity to light. But here's the twist: if new dimensions emerged, would we even be able to perceive them? Our senses and instruments are tuned to the three spatial dimensions and time that we're familiar with. A fourth spatial dimension, or even a fifth, might be so alien to our experience that detecting it would require entirely new ways of thinking and observing. This leads us to another fascinating question. What role would energy play in all of this? Because if dimensions are created or altered, energy would be the driving force behind it. In fact, energy might hold the key to understanding how a collision between universes could reshape the very fabric of existence. And that brings us to our next theory, where we'll explore how energy could act as the cosmic architect of a multiverse collision. What happens when two universes collide? One of the most fascinating possibilities lies in the redistribution of energy. Energy is the backbone of existence, the force that powers stars, galaxies, and even the vacuum of space. But in a collision of universes, this energy wouldn't just disappear, it would transform. Picture this: two immense cosmic structures, each brimming with their own unique forms of energy, slamming into one another. The result, a chaotic yet awe-inspiring reshuffling of power on a scale we can barely comprehend. According to the laws of thermodynamics, energy cannot be created or destroyed, it can only change forms. In the case of a universal collision, the energy from both universes would likely merge, creating entirely new configurations. Some of it might convert into heat, radiating outward in waves so intense they could outshine entire galaxies. Other portions could condense into matter, forming new stars, planets, or even exotic structures we've never seen before. And then there's the possibility of entirely new forms of energy emerging, phenomena that don't exist in our current universe but could arise from the unique interplay of two colliding realities. Take, for example, the concept of dark energy, the mysterious force driving the accelerated expansion of our universe. In a collision, this energy might interact with its counterpart from the other universe, leading to unpredictable outcomes. Could it amplify, creating a rapid expansion that tears the fabric of space-time, or could it cancel out, causing a sudden collapse? The redistribution of energy in such an event would be a cosmic dance of unimaginable proportions. But here's the real question: could this energy be harnessed? Imagine a civilization advanced enough to tap into the raw power of a universal collision. The sheer scale of energy released could fuel technologies beyond our wildest dreams, or perhaps it could be too volatile to control. The potential is as thrilling as it is terrifying. What new discoveries could we make about the nature of energy itself, and what risks would come with trying to wield such immense power? The answers lie in the mysteries of the cosmos, waiting to be uncovered. What if a collision between two universes could unlock a nearly limitless source of energy? This is the intriguing possibility behind the 25th theory: energy harvesting from a universe collision. Imagine tapping into the sheer force of such an event, where the immense energies released could dwarf anything we've ever encountered. But how feasible is this idea, and what would it take to make it a reality? The concept of energy harvesting from a universe collision draws inspiration from our current efforts in renewable energy. Think about how we capture solar power or harness wind energy. These are essentially ways of tapping into natural forces on a much smaller scale. A universe collision, on the other hand, would involve energies so vast that they could theoretically power civilizations for eons. The challenge, however, lies in developing the technology to not only detect and predict such an event, but also to capture and control its energy without catastrophic consequences. One of the biggest hurdles is the sheer scale of the forces involved. A universe collision would likely release energy in forms we can barely comprehend, perhaps even new forms of radiation or particles we've yet to discover. Developing the infrastructure to safely harness this energy would require breakthroughs in physics, engineering, and materials science. For instance, we'd need technologies capable of withstanding temperatures and pressures far beyond anything we've ever encountered, as well as methods to convert these extreme energies into usable power. But beyond the technical challenges, there are also ethical considerations. Who would control such a powerful energy source? Could it lead to conflicts or inequality on a cosmic scale? And what if the act of harvesting energy from a universe collision inadvertently destabilized our own universe? These are questions that would need to be addressed before any such endeavor could move forward. Interestingly, this theory also hints at the potential for entirely new industries. Just as the space race of the 20th century spurred advancements in technology and created entirely new fields of study, the pursuit of energy from a universe collision could do the same. From specialized spacecraft to energy conversion systems, the possibilities are as vast as the energies involved. It's a tantalizing thought, one that pushes the boundaries of what we consider possible. As we continue to explore the mysteries of the cosmos, the idea of energy harvesting from universe collisions reminds us that the universe is full of untapped potential. Whether or not this theory ever becomes a reality, it challenges us to think bigger, innovate boldly, and consider the ethical implications of our actions on a cosmic scale. And who knows, the energy solutions of tomorrow might just come from the most unexpected of places, like the collision of two universes. Now, let's shift our gaze from the cosmic to the practical. What would happen to our economies if two universes collided? It's a question that might sound like science fiction, but speculative economics gives us a fascinating lens to explore this idea. Imagine the sheer scale of resources that could become available if another universe merged with ours. Entirely new materials, energy sources, or even technologies might emerge, creating opportunities for industries we can't even fathom today. Think about it. A single new element or energy form from another universe could revolutionize manufacturing, transportation, or even healthcare. The economic ripple effects would be staggering, potentially reshaping global trade, markets, and currencies. But it's not just about resources. A collision of universes could also spark entirely new industries. For instance, if the laws of physics in the other universe differ from ours, we might see the rise of entirely new scientific fields or engineering disciplines. Companies could emerge to harness these unique properties, creating jobs and wealth in ways we've never seen. And then there's the question of currency. Could a universal collision lead to the creation of a new form of money, backed by resources or technologies from both universes? It's a wild thought, but history shows us that economies are always evolving, adapting to new realities. Of course, with opportunity comes risk. The sudden influx of new resources could destabilize existing markets, leading to economic upheaval. Industries that rely on current materials might collapse, while others could skyrocket overnight. It's a scenario that would challenge governments, businesses, and individuals to adapt quickly or risk being left behind. Speculative economics reminds us that while the unknown can be exciting, it's also unpredictable. But economies aren't just about numbers and resources, they're deeply tied to the societies they support. And that brings us to our next theory, the role of art and culture in the aftermath of a universal collision. How would such an event shape the way we create, express, and connect? Let's dive into that next. What if the collision of two universes didn't just reshape the cosmos, but also redefined how we see ourselves? Imagine the shockwaves of such an event rippling through every aspect of human life, not just science, but art, culture, and the very essence of how we express what it means to exist. A universe collision wouldn't just be a cosmic event. It could become a cultural milestone, a moment so profound that it sparks entirely new forms of creativity. Throughout history, humanity has turned to art to make sense of the unknown. Think about how the Renaissance was born from rediscovering ancient knowledge, or how the moon landing inspired a wave of music, literature, and visual art. A universe collision could be the ultimate muse, pushing artists and creators to explore themes of unity, chaos, and rebirth. Science fiction has already given us glimpses of this, works like Philip K. Dick's The Man in the High Castle, or the surreal, boundary-pushing art of H.R. Giger show how artists grapple with alternate realities and cosmic shifts. But in the wake of a real universe collision, the creative response could be even more profound. Imagine paintings that blend the aesthetics of two universes, where colors and forms collide in ways we've never seen. Or music that captures the dissonance and harmony of two realities merging, creating sounds that feel both alien and familiar. Even architecture might evolve, with buildings designed to reflect the duality of existence, structures that seem to bend space and time themselves. The collision wouldn't just be a scientific event, it would be a cultural explosion, a moment that redefines what art can be. But how would humanity remember such an event? Would it become a shared story, passed down through generations like myths of creation or destruction? Or would it fragment into countless interpretations, each culture weaving its own narrative around the cosmic dance? One thing is certain, a universe collision would leave an indelible mark on our collective imagination, inspiring art and culture for centuries to come. What if the collision of two universes wasn't just a cosmic event but a story waiting to be told? Imagine a moment so profound, so transformative, that it reshapes not only the physical fabric of existence but also how we remember and interpret it. This brings us to the fascinating 28th theory, the role of memory and history in the aftermath of a universe collision. When two universes collide, the sheer scale of such an event would challenge everything we know about recording and preserving history. Think about how humanity has documented its own past through oral traditions, written records, art, and more recently, digital archives. But what happens when the event is so vast, so incomprehensible, that it defies traditional methods of storytelling? Would it even be possible to capture the full scope of such a collision, or would fragments of it be all that survive? Historically, major events like wars, natural disasters, or even the moon landing have left indelible marks on collective memory. These moments are often woven into the cultural fabric, shaping identities and inspiring new narratives. A universe collision, however, would dwarf even the most significant events in human history. It could give rise to entirely new mythologies, symbols, and traditions as entire civilizations grapple with its meaning. Picture ancient cave paintings or epic poems, but on a cosmic scale, stories that attempt to explain the inexplicable. And then there's the question of perspective. Just as historical events are often interpreted differently depending on who's telling the story, a universe collision might be remembered in wildly varying ways across different worlds or dimensions. One civilization might see it as a rebirth, a chance to start anew. Another might view it as an apocalypse, a tragic end to everything they've ever known. These conflicting narratives could lead to rich, complex histories that evolve over time as new generations reinterpret the event. This raises another intriguing possibility, the emergence of new forms of storytelling. If traditional methods fall short, perhaps art, science, and imagination would merge to create entirely original ways of preserving memory. Imagine holographic archives, multidimensional art installations, or even shared consciousness experiences that allow entire populations to relive the collision. The collision itself could become a canvas for creativity, inspiring stories that transcend the limits of our current understanding. As we ponder how a universe collision might be remembered, it's impossible not to wonder, what would our own role be in shaping that narrative? Would we be storytellers, historians, or simply witnesses to a cosmic event beyond comprehension? And how might these new stories redefine not just our past but our future? What if the collision of two universes didn't just reshape the physical cosmos but also transformed something deeply human, the way we tell stories? Stories are how we make sense of the world, and a universe collision could shatter the very framework of our narratives. Suddenly, the boundaries of what we consider real or possible would blur, opening doors to entirely new genres, mediums, and ways of storytelling. Picture this, a world where the rules of physics, time, and reality are rewritten. How would storytellers adapt to such a profound shift? In this new reality, we might see the birth of genres that defy our current understanding. Imagine speculative fiction that no longer speculates but instead reflects the bizarre truths of a merged universe. Stories could explore the coexistence of multiple timelines, parallel selves, or even sentient cosmic forces. Think of how films like Inception or Interstellar challenged our perception of reality. Now amplify that by 1,000. Writers and filmmakers might craft tales where characters navigate not just one universe but fragments of many, each with its own rules, histories, and logic. Literature and film could also evolve in unexpected ways. Perhaps we'd see a resurgence of oral storytelling, where the fluidity of spoken word mirrors the chaotic nature of a colliding cosmos. Or maybe new mediums would emerge, immersive experiences that blend virtual reality with quantum mechanics, allowing audiences to step into multiple universes simultaneously. The collision could even inspire a fusion of artistic styles, combining the visual language of one universe with the narrative traditions of another. And let's not forget the role of the audience. In a world where universes collide, storytelling might become more collaborative. Imagine stories that adapt in real time based on the viewer's choices, reflecting the unpredictable outcomes of a multiverse. This could lead to a democratization of narrative, where the line between creator and consumer dissolves, and everyone becomes a co-author of the tale. As we ponder this evolution of storytelling, it's impossible not to wonder how technology would play a role in shaping these new narratives. From AI-generated universes to holographic projections, the tools at our disposal could redefine what it means to tell a story. And that brings us to the next theory: how technology might not just adapt to a universe collision but thrive in its aftermath. As we venture deeper into the mysteries of a universe collision, one question looms large: what role would technology play in such a cataclysmic event? Picture this: two universes, each with its own set of physical laws and technological advancements, crashing into one another. The consequences would be unimaginable, but so too would the opportunities for innovation. In the face of such chaos, humanity's ability to adapt and create could become our greatest survival tool. Consider how far we've come already. Today, we're harnessing technologies like quantum computing, artificial intelligence, and advanced materials science to solve problems that once seemed insurmountable. These tools could serve as a foundation for what comes next. Imagine, for instance, the development of hyper-advanced energy systems capable of harnessing the raw power of a universe collision. Or think about AI-driven simulations that could predict and mitigate the effects of such an event, giving us a fighting chance to prepare. But it's not just about survival, it's also about evolution. A collision between universes could introduce entirely new elements, forces, or even dimensions that our current technology can't even begin to comprehend. This might spark a technological renaissance, pushing us to invent devices and systems that bridge the gap between our universe and the unknown. For example, we might see the rise of interdimensional communication tools or spacecraft capable of navigating through the chaotic aftermath of such a collision. And then there's the question of adaptability. Could our existing technology be repurposed to handle the fallout? Think about how solar panels, originally designed to harness the sun's energy, might be reconfigured to tap into the energy of a collapsing star or emerging universe. Or how medical technologies could evolve to protect us from radiation or other hazards unleashed by such an event. So, could technology help us survive a universe collision? The answer is a resounding maybe. While we can't predict the exact nature of such an event, one thing is clear: our ability to innovate and adapt will be crucial. The collision of universes might be the ultimate test of human ingenuity, a challenge that could either propel us to unimaginable heights or leave us scrambling to pick up the pieces. And as we continue to push the boundaries of what's possible, we might just find that the tools we're building today could one day save us from the unimaginable. What if humanity found a way to survive the unimaginable, a collision between two universes? While the idea might sound like something straight out of science fiction, scientists and futurists have been exploring ways we might endure such a cosmic event. One of the most compelling strategies, space colonization. Imagine humanity spreading across the stars, establishing colonies on distant planets, or even building massive space habitats. This isn't just fantasy, it's a concept already in motion. Right now, organizations like NASA and private companies such as SpaceX are working on technologies to make interplanetary living a reality. Think of the International Space Station as a tiny prototype for what could one day become humanity's lifeline in the face of universal chaos. But colonization alone might not be enough. Enter genetic engineering, a tool that could allow us to adapt to the harsh conditions of other worlds or even survive the aftermath of a universe collision. By altering our DNA, we could potentially withstand extreme temperatures, radiation, or even thrive in environments with scarce resources. Scientists are already experimenting with CRISPR and other gene editing technologies, paving the way for a future where humans are no longer bound by the limitations of our biology. Picture this, a new breed of humans designed to thrive in the void of space or on planets light years away from Earth. It's a radical idea, but one that could redefine what it means to be human. And let's not forget the social and cultural shifts that would come with such survival strategies. If humanity were forced to leave Earth behind, we'd likely see the rise of entirely new forms of society. Colonies on distant worlds might develop their own unique cultures, governance systems, and ways of life, shaped by their environments and the challenges they face. This could lead to a fascinating evolution of human civilization, one that blends technology, biology, and innovation in ways we can barely imagine today. The survival of humanity in the face of a universe collision isn't just about science. It's about resilience, creativity, and the unyielding drive to push beyond our limits. Whether through space colonization, genetic engineering, or the emergence of new societal structures, one thing is clear: humanity has the potential to adapt and endure, even in the face of the cosmos' most catastrophic events. What if a collision between two universes didn't just reshape the cosmos, but also redefine the very fabric of society? When we think about such an event, it's easy to focus on the cosmic chaos, exploding stars, merging galaxies, and the birth of strange new worlds. But what about the people? How might societies adapt or even emerge anew in the aftermath of such an unimaginable event? Picture this: two universes collide, and suddenly, the inhabitants of both are thrust into a shared reality. At first, there might be confusion, even fear, as the rules of existence shift. But over time, something fascinating could happen. New social structures could begin to form. Sociologists and anthropologists suggest that when groups face shared challenges, they often come together in unexpected ways. Cooperation might flourish as people from both universes work to survive in this strange, blended reality. Imagine the possibilities: technologies and ideas from two entirely different histories merging, sparking innovations that neither universe could have achieved on its own. But let's not sugarcoat it. Conflict could also arise. Differences in values, beliefs, or even basic survival needs might lead to tension. History shows us that when cultures collide, the results can range from peaceful assimilation to violent clashes. In this new, shared universe, the stakes would be infinitely higher. Would societies find common ground, or would the collision create a fractured world, divided along the lines of its cosmic origins? This brings us to an intriguing question: what role would ethics play in shaping these new societies? When the old rules no longer apply, how would people decide what's right or wrong in this uncharted reality? This leads us seamlessly into our next theory, where we'll explore the ethical dilemmas that could arise in the wake of a universe collision and how they might shape the future of life itself. What if two universes collided not just physically but ethically? Beyond the mind-bending physics and cosmic chaos, there's a deeper question we need to confront. What happens to morality when the rules of reality as we know them are rewritten? A collision between universes wouldn't just challenge our understanding of space and time. It would force us to grapple with some of the most profound ethical dilemmas imaginable. Let's break this down. First, consider resource allocation. In a universe collision, resources, whether they're planets, energy, or even habitable zones, might suddenly become scarce or wildly unpredictable. Who gets access to these resources? Would it be based on strength, intelligence, or some universal moral code? Philosophers like John Rawls have argued for principles of fairness and justice, but in a scenario where two entirely different sets of life forms are competing for survival, how do we even begin to define what's fair? Then there's the question of survival priorities. If two universes collide and life forms from each are thrown into a shared, chaotic reality whose survival takes precedence, would we prioritize our own species, or would there be a moral obligation to consider the existence of beings from the other universe? Utilitarianism, a philosophy that advocates for the greatest good for the greatest number, might suggest trying to save as many lives as possible, regardless of their origin. But is that even practical when resources are finite and the stakes are existential? And what about the value of life itself? If the other universe contains life forms that are radically different from ours, perhaps not even carbon-based, how do we assign value to their existence? Immanuel Kant's idea of treating individuals as ends in themselves rather than means to an end might offer a starting point. But in a collision scenario where the very fabric of reality is in flux, would such principles hold? Or would we be forced to adapt our ethical frameworks to a new, unimaginable reality? So, how would we define morality in such a scenario? Would it be shaped by necessity, by survival, or by something deeper, a shared understanding of what it means to coexist in a universe that's no longer just ours? These are questions that don't just belong to the realm of science fiction. They force us to confront the very foundations of our ethical beliefs. And as we ponder them, one thing becomes clear. A universe collision wouldn't just reshape the cosmos, it would reshape how we see ourselves. What if the collision of two universes didn't just reshape the physical cosmos, but also the very foundations of how we understand right and wrong? This brings us to an intriguing thought. Could such an event force us to redefine morality itself? Imagine a scenario where the merging of universes introduces entirely new forms of life, consciousness, or even realities where the rules we've always lived by no longer apply. Would our ethical principles hold up, or would we need to rethink them entirely? Moral philosophy has long grappled with questions about what defines good and evil, justice and fairness, and the nature of human values. But what happens when those values are suddenly confronted with something entirely alien, not just in the sense of extraterrestrial life, but in the sense of a reality so different that our current frameworks might seem outdated or irrelevant? For example, if a universe collision led to the existence of beings whose very survival depended on actions we consider unethical, would we adapt our morality to accommodate them? Or would we hold fast to our principles, risking conflict or irrelevance? Philosophers like Immanuel Kant argued that morality is rooted in universal principles, rules that apply to all rational beings, no matter the context. But what if the collision introduced beings that operate on a completely different kind of rationality? Would Kant's categorical imperative still hold, or would we need a new ethical framework to bridge the gap between our universe and theirs? Similarly, utilitarianism, which focuses on maximizing happiness, might face challenges if the collision created realities where happiness itself is defined in ways we can't yet comprehend. This isn't just a thought experiment, it's a profound question about the adaptability of human thought. A universe collision might not only expand our physical horizons, but also spark a new era of philosophical exploration. It could lead to the creation of entirely new ethical systems, blending the best of what we know with the possibilities of what we've yet to discover. And in doing so, it might push humanity to evolve not just scientifically but morally as well. So, as we ponder the collision of universes, let's also consider the collision of ideas, how such an event could challenge us to rethink not just the cosmos but our place within it. Could this be the beginning of a new chapter in human thought, one where morality itself is redefined? The answers might be as vast and complex as the universes themselves. As we wrap up this exploration of what might happen if two universes collided, let's take a moment to reflect on the incredible theories we've uncovered. The idea of a cosmic collision between universes isn't just science fiction, it's a profound possibility that challenges our understanding of reality. From the chaotic merging of physical laws to the potential birth of entirely new dimensions, these theories push the boundaries of what we think we know about existence. They force us to ask, what defines a universe? Could there be realms beyond our own, operating under rules we can't even imagine? These are the kinds of questions that keep scientists and dreamers alike awake at night. But beyond the mind-bending physics, there's something deeply human about this topic. It reminds us that the universe or universes are vast, mysterious, and full of surprises. Every theory we've discussed today, from the collision of matter to the creation of new cosmic structures, hints at the potential for discovery on a scale we can barely comprehend. It's a reminder that science isn't just about answering questions, it's about asking better ones. And in the case of colliding universes, those questions might just lead us to redefine everything we thought was possible. As we close, let's leave you with this thought from Carl Sagan. Somewhere, something incredible is waiting to be known. Whether it's the collision of universes, the birth of new realities, or the unraveling of cosmic mysteries, the universe is a place of endless wonder. And while we may not have all the answers yet, the journey of discovery is just as thrilling as the destination. So, what do you think might happen if two universes collided? Could it be the start of something entirely new or the end of everything we know? Let us know your thoughts in the comments below. We'd love to hear your ideas and theories. And if you enjoyed this dive into the unknown, don't forget to subscribe for more mind-expanding explorations of the cosmos. The universe is vast and the possibilities are infinite. Stay curious and keep looking.